Welcome once again to your favorite channel, Israeli Math Concept. In today's tutorial, I'm going to profess solution to this given question on the board. The question is about how to find the derivative of these given functions. Remember, if today is your first time of viewing, consider subscribing to my YouTube channel, Israeli Math Concept. You can as well follow me on Facebook, comment on my videos, like and reshare my videos as well. Remember, to differentiate a given function of this form, there is need for you to recall your basic laws of indices. Let's read out the question first of all. The question says differentiate the following with respect to their variables. The number one part of the question says y is equal to 1 over x raised to the power of 2. The number two part of the question, t is equal to 3 over x raised to the power of 6. Why the third part of the question? This one is looking for trouble. If y is equal to 10, we are then asked to find the y dx. That is to find the derivative of y with respect to x. Okay, let's begin with the first part of the question. Remember I said prior, if you must be able to solve this given question, most especially the number 1 and 2, there is need for you to recall your basic laws of indices. And guess what? I have videos on laws of indices on my YouTube channel. You can as well check it on my Facebook page. Scroll down a little bit and you're gonna find it. Then restudy it and get acquainted with it. I guess it will help you to solve a given problem of this kind. Let's proceed with the number one question. Solution. So we want to differentiate the function y equal to the reciprocal of x raised to the power of 2. But before then, remember that the general formula method of differentiating a function is giving us if we have a function like y equal to ax raised to the power of n. To differentiate this function, we shall say differentiating y with respect to x will be equal to multiplying this given term by the power n. So we have ax raised to the power of n multiplied by the power n. Then I will subtract 1 from the power. This is the basic formula we know on how to differentiate a given function. We still have other methods of that, which are first principles and otherwise. But this is the basic one, okay? So this is n multiplied by a, which is still an, then x raised to the power of n minus 1. So I will be using this basic method of differentiation to differentiate this given function here. So first thing first, I will apply the law of indices that says that whenever we have a given base raised to a negative power, that we can still put it as the reciprocal of that given base a raised to the positive power of the initial power. Remember, the initial power is negative 2. So when we take the reciprocal of it, we take the positive value of 2 or the absolute value of 2. This is one of the basic law of indices we know. Okay, coming back here, I will apply this law of indices here in this given place. Hence, I have y equal to 1 over x raised to the power of 2 can still be put as x raised to the power of negative 2. That sounds very simple, right? Okay, let's go ahead to differentiate this formula using this basic method of differentiating a function. So we then say differentiating y with respect to x is then equal to, I will then multiply this given term, x raised to the power of negative 2. I will multiply it by the original power of negative 2. Okay? Then I will subtract 1 from this original power. That is exactly the formula we have here. Okay? And that is equal to, I will then say that the y, the x, remember this is the short form of saying differentiating y with respect to x. You can easily call it the y, the x. So my dy dx is equal to negative 2 multiplied by x raised to the power of negative 2 minus 1 will still give us negative 2x raised to the power of, remember that minus 2 minus 1 will still give us negative 3. Okay? And this is equal to, I have negative 2 multiplied by, remember that by the law of indices which we just applied here, we can put x raised to the power of negative 3 as the reciprocal of x raised to the power of 3. Okay, this is the law of indices we apply here, and that is what we are using here. Such that this is equal to, remember that negative 2 multiplied by 1 is still negative 2, and that is all over x raised to the power of 3. So this is basically our answer. That is very simple, right? Let's then take the second question. From the second question, we have that t is equal to 3 over s raised to the power of 6. Remember, this can still be put as t is equal to 3s raised to the power of negative 6. I just apply this law of indices here. Remember that 3s raised to the power of negative 6, 3s raised to the power of negative 6 is the same thing as saying 3 multiplied by s raised to the power of negative 6, taking the reciprocal, we have the positive value of 6, and this is equal to 3 multiplied by 1 is 3, and that is all over s raised to the power of 6. Okay, so what we have here is exactly what we have here. Okay, so automatically this can still be put as this, and that is what we have here. So let's then differentiate t with respect to s. So we have the differentiating t with respect to s, and that is equal to, I will then multiply 3s raised to the power of negative 6. I will multiply it by the initial power, which is negative 6. Then I will subtract 1 from this power. I'm just applying this formula here, okay? Then this is equal to negative 6 multiplied by 3 will give us negative 18. Then s raised to the power of negative 6 minus 1 will give us negative 7. Then solving further, remember that the value we have initially is in fractional form, so we have to leave this in fraction as well. Though if you leave your answer like this, it's still correct, but it's more convenient to put your answer in fractional form. Then we have negative 18 multiplied by, we can still convert s raised to the power of negative 7 as 1 over s raised to the power of 7. That is taking the reciprocal of it based on the law of indices we have here. Then our dt dx, that is differentiating t with respect to the s, which is our derivative, is equal to negative 18 multiplied by 1 will give us negative 18, and that is all over our s raised to the power of 7. S raised to the power of 7. So here is our answer. Alright, let's take the last question, which is the third question. The question says, if y is equal to 10, we should find the y, the x. It is very simple. First thing first, let's put down the question, y is equal to 10. Remember that we can still put this as y equal to 10x raised to the power of 0. Because whatever we have here is the same thing as whatever we have here. Let's break this 10x raised to the power of 0 using the law of indices. 10x raised to the power of 0, which implies 10 multiplied by, remember by one of the law of indices, which says that any number raised to the power of 0 is 1, such that 10 multiplied by 1 will still give us 10. Hence, 10x raised to the power of 0 is the same thing as 10. That was why I had to say that 10 is the same thing as saying 10x raised to the power of 0. Take note of that. Then differentiating y with respect to x is equal to, using this same formula we have here, the term we have here, which is 10x raised to the power of 0, we shall multiply it by the original power of 0. Then we shall subtract 1 from the power. Without taking much time, 0 multiplied by everything we have here is still 0. So 0 is the answer. So take note that the differentiation of a constant, 10 is a constant, right? So the differentiation of any constant at all, it mustn't be 10. It could be any number like 20, 30. Just take note that the differentiation of any constant will easily tend you to 0. So you don't need to take more time to solve for this. You can as well just tell us that the differentiation of a given constant will give you 0. But for convenience, you can as well solve it like this, okay? Thank you for viewing. Thank you for watching. If you found this video useful, remember to reshare this video and at the same time subscribe to my YouTube channel. It's really math concept. Hit on the notification bell right there so that whenever I drop a new math content, you would be notified. Remember to reshare this video. Goodbye.